Hello students, welcome to Educate. In the last video, we have discussed about Raoult's law as well as the azeotropic mixture. In this video, we will discuss about colligative properties. What is colligative properties? Those properties of the solution which only depend on the number of moles of solute and do not depend on the nature of solute or the solvent particles. That means those properties of the solution which only depend on the relative number of moles of solute particles and do not depend on the nature of solute or the solvent particles. That is here colligative properties, already mentioned here, written in the NCERT books. All these properties depend on the number of moles of solute particles irrespective of their nature relative to the total number of particles present in the solution. Such properties are called colligative properties. To those students for whom this definition is clear, may write this one. Otherwise, may write like this one: the properties of solution which depend on the number of moles of solute particle or relative number of moles of depend on the relative number of moles of solute particles and do not depend on the nature of solute or solvent particles. Because I have written in simplified word, that's why you can choose this one and you should choose this one. That means the properties of solution which depend on the relative number of moles of solute particles and do not depend on the nature of solute or solvent particles. That is called colligative properties. Next, this colligative properties is of four types. Relative lowering of vapor pressure, number one here. In addition to that, elevation in boiling point, depression in freezing point, and osmosis. The colligative properties is of four types: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmosis. That means what will be the relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and the osmosis? They will depend only on the number of moles of solute particles and will not depend on the nature of solute or the solvent particles. Okay, let's see. First of all, relative lowering of vapor pressure. Those students who are preparing for IIT main or for NEET examination, those students should observe the expression. But the students who is preparing for 12th board examination only and he have no any admission for the IIT main or for the NEET examination, those students will not have to consider about this one, because in 12th board examination question don't ask derive the expression for relative lowering of vapor pressure. But let's see how's that relative lowering of vapor pressure. The expression is there. I am also deriving. Listen here. What is here? relative lowering of vapor pressure. That means, what's the meaning of this one? Relative lowering of vapor pressure. That means there is a solvent that will have some vapor pressure. When a solid will dissolve in that solvent, then the vapor pressure of the solution will decrease. Relative lowering of vapor pressure means how much vapor pressure will decrease when a solid will dissolve in a liquid solvent. With respect to the vapor pressure of the liquid solvent in pure state. Relative lowering of vapor pressure means decrease in vapor pressure with respect to the vapor pressure of a solvent when a solid solute will dissolve in the liquid solvent. Okay, so let's see. As you already know, vapor pressure when a solid dissolves in a liquid, then the vapor pressure of the solution will be equal to mole fraction of solvent into vapor pressure of that solvent in pure state. Vapor pressure of a solution will be equal to mole fraction of the solvent into the vapor pressure of that solvent in pure state. That means P1 will equal to Chi1, P degree 1. So how much decrease in vapor pressure? Here decrease in vapor pressure, this one. So initial vapor pressure was P degree 1 and the vapor pressure of solution is P1. So in vapor pressure initially the vapor pressure of solvent was P degree 1 and the vapor pressure of solution is P1. So change in vapor pressure is P degree 1 minus P1 and P1 equal to Chi1 P degree 1. So on the place of P1 that has been written P degree 1 Chi1. Now P degree 1 here, P degree 1 here, so that has been taken common. So P degree 1 when I have taken common, so that will be P degree 1 into 1 minus Chi1. And it is a binary solution. As you know, for binary solution, Chi1 plus Chi2 equal to 1. So 1 minus Chi1 that will equal to Chi2. So on the place of 1 minus Chi1 it can be written Chi2. So change in vapor pressure will be equal to Chi2 into P degree 1. That means the change in vapor pressure will be equal to mole fraction of solute into the vapor pressure of the solvent in pure state. And it is relative lowering of vapor pressure. Means this is the lowering of vapor pressure. Relative lowering means that was the change in vapor pressure, and relative means with respect to initial vapor pressure. That means with respect to how much vapor pressure change in the vapor pressure with respect to the vapor pressure of solvent in pure state. That's why delta P1 upon P degree 1 that will be equal to this one change in vapor pressure upon original vapor pressure, that will equal to Chi1, because P degree 1 here when you write here, so Chi2 into P degree 1. So delta P1 upon P degree 1 that will be equal to Chi2 P degree 1 upon P degree 1. This P degree 1, this P degree 1 cancel out. So this change in vapor pressure with respect to the vapor pressure of solvent in pure state will be equal to mole fraction of solute. Okay guys, so here and for 12th board examination only you will have to keep in the mind that the change in vapor pressure, that means lowering of vapor pressure with respect to the vapor pressure of solvent will be equal to the mole fraction of solute. Okay, so that is here expression. Let's see, proceed here. There, this one. So expression here, it is very simple. Change, this is here change in vapor pressure, P degree 1 minus P1, that means change in vapor pressure, and it is P degree 1. That means it is actually the expression delta P upon P1 upon P degree 1. This one equal to mole fraction. So mole fraction of solute, that will equal to number of moles of solute upon number of moles of solute plus number of moles of solvent. This one. And for it is of binary, when a solid solute will dissolve in a liquid, then usually the amount of solute or the number of moles of solute will be very less compared to the number of moles of solvent. The number of moles of solute will be very less than that of solvent. So that means N2 will be equal to, N2 will be very less. N2 will be very less than N1. That's why N2 plus N1 plus N2 will be nearly equal to N1. That means number of moles of solute plus number of moles of solvent plus number of moles of solute will be approximately equal to the number of moles of solvent only. So that's why this value can be ignored. So that's why change in vapor pressure with respect to original vapor pressure means the vapor pressure of solvent, that will be equal to N2 by N1. And how you know? The number of moles of solute will be equal to given weight of solute upon molecular weight of solute, that is here, and number of moles of solvent will be given weight of solvent upon molecular weight of solvent. So that's why on the place of N2, that can be written here, on the place of N2, that can be written as W2 by M2, that upon here W1 by M1. So this is the main division line. So that will equal to W2 upon M2 into M1 by W1. So that is here W2 M1 M2 W1, this one. So relative lowering here, this one, lowering of vapor pressure with respect to the vapor pressure of solvent, that will be equal to W2 M1 upon M2 W1. This is the expression. For 12th board examination, if you will keep this formula in your mind, and then you can very easily solve the numerical questions based on this topic, that is relative lowering of vapor pressure. But if you are also thinking about the IIT mains or the IIT advanced as well as about the NEET examination, then you should also consider about the derivation, how this one has came, in how that has been came, that you will have to understand only that much. But if you will try to mug up, that will be worthless. So don't waste your energy, of which you will not get the result. Now let's see about this question. What the question is here? Question here is the vapor pressure of pure benzene at a certain temperature is this much, or non-volatile non-diluted this much. So in this question, the vapor pressure of pure benzene at this one given is that much. It is given the vapor pressure of benzene. Here benzene is solvent. So this one is the vapor pressure of solvent. So that means P degree 1 is 0.850. Now 0.5 gram of the non-volatile solute is added there. So that means W2 is 0.5 gram. This is 0.5 gram is the weight of solute and weight of solvent is 39 gram. So W1 equal to 39 gram. Vapor pressure, total vapor pressure has been given 0.845. So P1 has been given 0.845 bar. To solve this question, one way is directly put the data in the formula and get the result. But I am telling you by the concepts how you will solve this question. Because if you will adopt this attitude by how to solve this question by the concept, then that will be helpful for you to crack the IIT main, advanced as well as to NEET examination. So let's see here how to solve this one. So P degree 1 is given, P1 is given. So change in vapor pressure will be how much? Change in vapor pressure. That means P degree 1 is that much and P1 is this much. So 0.850 bar minus 0.845 bar. So that will be equal to 0.005 bar. Change in vapor pressure will be that much. So, and relative loading of vapor pressure, that means delta P upon P degree, that will be equal to 0.005 bar upon 0.850 bar, 0.850 bar, and that is equal to mole fraction of solute. Bar will cancel out. So this decimal cancel out. So that will be equal to 5 upon 850. So 5 upon 1 upon 170. So mole fraction of solute will be equal to 1 upon 170. That will be mole fraction of solute. So what is the molar mass of solid substance? So mole fraction of solute, that will be equal to number of moles of solute upon number of moles of solvent directly take. Because now here mole fraction, the value of mole fraction is also here very less. Mole fraction of solute is very less. That means very less amount of solute is present in the solvent. Mole fraction of solute is less means the number of moles of solute in a particular solvent will be very less. So that's why in addition N1 and N2 can be ignored. So now number of moles of solute, that will be equal to mole fraction of solute into number of moles of solvent. So number of moles of solute, mole fraction of solute you have calculated 1 upon 170, and here number of moles of solvent. So number of moles of solvent, how to find out? 39 gram of benzene has been dissolved and molecular weight of benzene is 78. So that will be 39 gram upon 78 gram per mole. So gram will cancel out, mole will go above. So that will become mole inverse will go in the numerator, that become mole, that upon 2. So that will be number of moles of solute. Number of moles of solute will be equal to 1 upon 170, 1 upon 170 into 2. That much mole. That means 1 upon 340 mole. Now you have to find out molecular weight. So molecular weight you know, that means number of moles is equal to given weight of solute, that means weight of solute upon molecular weight of solute. So molecular weight of solute, this will comes this side. So molecular weight of solute, that will be equal to weight of solute upon number of moles of solute. So weight of solute here given how much? 0.5 gram has been dissolved. So that will be 0.5 gram, that upon number of moles is 1 upon 340, that much mole. So its unit will be gram per mole, and this is the main division line. So that will be 0.5 into 340. So decimal will cancel out by the 0. 5 4 is 20, 5 3 is 15, and 2 70. So 117, this one will be, and here gram, and it is a mole. So that means gram per mole. So molecular weight of that solute will be 170 gram per mole. So that means molecular weight of non-volatile solute will be 170 gram per mole. Okay guys, very easy, and by the concept if you will do, then a number of questions there will be. Those type of questions you could solve very easily without exerting any stress on your mind. And if you are preparing for 12th board examination, you may also adopt this technique that put the data in the formula and get the result. Okay, whichever you would like, that's do. Now, next colligative property is elevation of boiling point. There is 4 colligative properties. One is relative lowering of vapor pressure. Relative lowering of vapor pressure. Next one is elevation in boiling point. Third one is depression in freezing point. And fourth is osmosis. Relative lowering of vapor pressure means when a solute will dissolve in a liquid solvent, when a solid solute or any non-volatile solute will dissolve in a liquid solvent, then there will be decrement in the vapor pressure of this solution. And relative lowering means the lowering in vapor pressure with respect to the vapor pressure of solvent. In the same, that was relative lowering of vapor pressure. Elevation in boiling point, when a non-volatile solute will dissolve in a liquid solvent, then the boiling point of the resulting solution will increase. So, elevation in boiling point. Boiling point will increase, but the depression in freezing point, that will decrease. So, when a non-volatile solute will dissolve in a liquid solvent, the boiling point of the resulting solution will increase and the freezing point will decrease. So, that was elevation in boiling point and depression in freezing point. Next term will be osmosis. So, about the osmosis we will go later on, okay, in this video only. So, elevation on boiling point, that is the meaning of elevation in boiling point. When a non-volatile solute will dissolve in a liquid solvent, then their vapor pressure and then their boiling point will increase. And why that will increase and how much, about that we discuss by this graph. You already know, everyone, the vapor pressure of solution will be always lower than that of pure solvent. Already know, everyone know that the vapor pressure of solution will be lower than that of pure liquid solvent. So, here is a graph with respect to temperature. If you will increase the temperature of any liquid or the solution, more and more liquid particles will undergo in the vapor phase, and hence the vapor pressure will increase. So, this is the graph. Here, when temperature increases, the vapor pressure of the solution is increasing. Here also, when the temperature of the solvent will increase, their vapor pressure will also increase. So, this is the graph. If you will decrease the temperature, vapor pressure will decrease, That will be valid for both solute as well as solvent. So, let us see what happened here. What is boiling point actually? Firstly, what is boiling point? Boiling point is the temperature at which the vapor pressure of liquid will become equal to atmospheric pressure. As you will increase the temperature, then the vapor pressure will increase. The vapor pressure of solution as well as that of the solvent will increase on increasing the temperature. So, at which temperature the vapor pressure of liquid or the solution will become equal to atmospheric pressure, that temperature will be called boiling point. So, boiling point is the temperature at which the vapor pressure of liquid solvent or the solution become equal to atmospheric pressure. So, boiling point is the temperature at which the vapor pressure of liquid solvent or the solution will be equal to atmospheric pressure. So, let's see here, this is the graph of solvent. So, as you increase the temperature, the boiling point of the solvent increases. Like at this temperature, the boiling point is this much. At this temperature, you have increased the temperature. At this temperature, the boiling point is this much. At this temperature, atmospheric pressure is 1 atm or 1.013 bar. One atmospheric pressure will be equal to 1.013 bar. So, at this temperature, the vapor pressure of this solvent became equal to 1 atm. So, this temperature is the boiling point of solvent. This temperature is the boiling point of solvent. Okay. Now, consider about the graph of the vapor pressure of solution and the temperature. As you will increase the temperature, the boiling point of this solution will increase. As for example, at this temperature, the boiling point of the solution is this much, which is less than 1 atm. At this temperature, the boiling point of the solution is that much. At this temperature, the boiling point of the solution is that much. At this temperature, the boiling point of solution has not become equal to 1 atm. So, this temperature is not the boiling point of the solution. At this temperature, the vapor pressure of the solution is lower than the atmospheric pressure. So, this temperature is not the boiling point of the solution, but this temperature is equal to this. At this temperature, the vapor pressure of the solvent is equal to atmospheric pressure. That's why this temperature is the boiling point of the liquid solvent. Now, at this temperature, the vapor pressure of the solution is equal to 1 atm. That's why this temperature is the boiling point of the solution. This temperature is boiling point of solution. This temperature is the boiling point of solution. So, this temperature is the boiling point of solvent and this temperature is the boiling point of solution. So, boiling point has increased. This temperature, boiling point, when you have converted a solvent to the solution, then the boiling point has increased. And this increment, that is elevation in boiling point. That means this delta TB, that will be equal to this TB and here minus T degree B. Okay. So, that is elevation in boiling point. This one is elevation in boiling point. that will be equal to this TB minus T degree B. Okay. So what's the relationship here? In the relative lowering of vapor pressure, there was the relationship of directly proportional in terms of mole fraction. Here, in case of elevation in boiling point as well as in depression in freezing point, the direct relationship will be in terms of molality. So here this law here tells that delta TB, that means elevation in boiling point. Elevation in boiling point will be directly proportional to molality of the solution. Remove the proportionality constant, so there will be remove this proportionality sign, so there will be a proportionality constant, that is Kb. This Kb is called boiling point elevation constant or molar elevation constant, and most importantly is ebullioscopic constant. Ebullioscopic constant will be frequently given in the board examination. So usually in board examination, what's the value Kb? Kb will be written as ebullioscopic constant. So keep in the mind this Kb. Now molality here, you know already, given with weight of the number of moles of solute in 1 kg of solvent. That means number of moles of solute upon weight of solvent in kg. If that solvent, weight of the solvent will be given in gram, that is molality. So that will be, you will have to convert it to kg. If the weight of solvent will be given in gram, then you will have to convert the weight of solvent in kg. So that will be equal to number of moles of solvent upon weight of, number of moles of solute, that will be number of moles of solute upon, this is number of moles of solute upon weight of solvent in gram, that upon 1000. How you find out number of moles? So number of moles of solute, that will be equal to weight of the solute upon molecular weight of solute. So that will be equal to weight of solute upon molecular weight of solute, and that upon molality, that will be equal to here. So weight of solute by molecular weight of solute, that upon weight of solvent in gram upon 1000. This is the main division line. So that's why molality will be equal to weight of solute, that will be given in gram, that upon, so the solute in gram, that should be also you should write. So weight of solute in gram, that upon molecular weight of solute into 1000 upon weight of solvent in gram. So that is here, that's why here that is written 1000 into W2 means weight of solute in gram, that upon molecular weight of solute into weight of solvent in gram. That is. So Kb here, delta Tb, so here multiply by Kb, so that's Kb here. So M2 you can also find out, M2 will come this side, delta Tb will come this side, so that is here. Okay, so very easy this one expression is, and here no need to become panic to solve the numerical question. Let's see here how to solve this question. 18 what the question is given here in the question? 18 gram of glucose dissolved in 1 kg of water in a saucepan. At what temperature will water boil at this much bar? 1.013 bar means 1 atmospheric pressure. Kb for water is given 0.52 Kelvin kg per mole. Means question is telling that when 18 gram of glucose will dissolve in 1 kg of water, then what will be the boiling at what temperature the boiling water will boils. That means when 18 gram of glucose will dissolve in 1 kg water, then what will be the boiling point of resulting solution? This one is asking. And Kb for water has been also given. So you already know delta Tb, that means elevation in boiling point. That will be equal to Kb into molality of solution. Kb given here already. So delta Tb, if you will know the boiling point will increase through what value, and the boiling point of water is 100 degrees Celsius, it is well known. So through what value there will be increment in the boiling point of the solution. That means what will be the elevation in boiling point. If that you will calculate, then what will be the boiling point of water, that you can calculate very easily. Solution delta Tb equal to Kb into molality of solution. So how to calculate the molality? Molality, how you will calculate? So molality is number of moles of solute. So number of moles of glucose here. Glucose is solute. Number of moles of glucose, that upon weight of water in kg. So weight of water is given here 1 kg. So molality will be number of moles of glucose upon weight of water, and weight of water is given 1 kg. So simply here molality in this case will be equal to number of moles of glucose. So number of moles of glucose will be how much? So glucose here, weight of glucose upon molecular weight of glucose. So molecular weight of glucose C6H12O6. So that will be 12 into 6 plus 12 plus 16 into 6. This one 6 and 4. 10 carry 1. 9 1 10, 7 16 and 1 17. No, 18. So 180. So here 180 gram per mole, that upon 1 kg. Molality will be that much. So 180, that become 10. That will be 0.1 mole per kg. Gram will cancel out. So that will be molality of solution is 0.1 mole per kg. So molality is 0.1 mole per kg. That will be, so delta Tb equal to, Tb given a Kb 0.52 Kelvin kg per mole, that into molality of solution 0.1 mole per kg. So kg and kg inverse will cancel out, mole inverse and mole will cancel out. So only left will be Kelvin. So 0.52 into 0.1, that will be delta T will equal to 0.052 Kelvin. That means when 18 gram of glucose will dissolve in 1 kg water, then the boiling point of the resulting solution will increases by 0.052 Kelvin. So the boiling point of solution will be how much? So that will be equal to boiling point of water plus 0.052, that much Kelvin. And boiling point of water, we know that 100 degrees Celsius is the boiling point of water. That means 373.15 Kelvin is the boiling point of water. So 373.15 plus 0.052. That means 373.15 Kelvin plus 0.05 Kelvin. Add them, and then after you will get 373.2 Kelvin. Okay guys, so that is here how to solve this question. Very easy question it is. .2 Kelvin we have calculated. Then after this here, the boiling point of benzene is given Then when 1.80 gram of non-volatile solute dissolved in 90 gram of benzene. So weight of benzene has been given, the boiling point raised to this one, calculate the molar mass of the solute. Kb for benzene is this much. Very easily you can solve this question. If anyone will feel difficulty to solve this question, then comment in the comment box. I shall solve this one question. How to solve? I shall guide you in the next video after receiving your comment. Then next point is depression in freezing point. Depression of freezing point. What is freezing point? So freezing point is the temperature at which the vapor pressure of frozen solvent will be equal to the vapor pressure of liquid. The freezing point is the temperature at which the vapor pressure of a liquid in solid phase will be equal to the vapor pressure of that liquid in liquid phase. Like that, when we tell the freezing point of water is 0 degrees Celsius, that means at 0 degrees Celsius, the vapor pressure of ice will be equal to the vapor pressure of liquid water. Okay, when we tell the vapor, the freezing point of water, when we tell the freezing point of water is 0 degrees Celsius, that means at 0 degrees Celsius, the vapor pressure of ice will be equal to the vapor pressure of liquid water. Let's see here why when a solid dissolves in a liquid, their freezing point decreases. Why? About that we discuss. Listen here. Suppose here there is a ice or any frozen solvent here. It is frozen solvent, means solvent in solid phase, or that is also called frozen solvent. So what happened at freezing point? The vapor pressure of this frozen solvent and the vapor pressure of this liquid, that means liquid solvent, the vapor pressure of frozen solvent and the liquid solvent, that will be equal at freezing point. Okay, so let's see here, and when we increase the temperature, the vapor pressure increases. The vapor pressure of liquid as well as that of the solid will also increase. So let's see here, at this temperature, the vapor pressure of the vapor pressure of this liquid solvent and will be equal to this frozen solvent. So this temperature is the freezing point of pure solvent. This temperature is the freezing point of liquid solvent. But the vapor pressure of this solution is this much. That means at that temperature, the vapor pressure of liquid solvent will be equal to that of frozen solvent, but the vapor pressure of the solution is not equal to that of the frozen solvent. It is lower than the vapor pressure of frozen solvent. So this temperature is not the freezing point of solution. This temperature is not the freezing point of solution. This temperature is the freezing point of liquid solvent. Now again, decrease the pressure or decrease the temperature. So when you will decrease the temperature, the vapor pressure of solution will also decrease, and that of the frozen solvent will also decrease. Yes, the decrease in the vapor pressure of frozen solvent will be more vigorous compared to that of the decrease in vapor pressure of solution. So now at this temperature, the vapor pressure of this solution is this much, and that of the frozen solvent is also this much. That means at this temperature, the vapor pressure of solution has become equal to the vapor pressure of frozen solvent. So this temperature is the freezing point of the solution. This temperature is the freezing point of liquid solvent, and this temperature is the freezing point of solution. So freezing point has been decreased. So there will be, when a solid solute or any non-volatile solute will dissolve in a solvent, then the freezing point of resulting solution will decrease. Okay, this one. Now same as you have derived, the delta TF equal to same KF into molality of the solution, as you have derived in case of elevation in boiling point, same there, but their delta TF is depression in freezing point. This delta TF is depression in freezing point. There was elevation in boiling point, here depression in freezing point into molality of solution, that one. So delta TF will be equal to KF into molality of solution, and in the same way that will derive. That has been derived. Same way as we had derived in elevation in boiling point. Guys, here is the table of the value of Kb. Kb means ebullioscopic constant, and this Kf means cryoscopic constant. This Kf has been given, and no need to mug up for your examination. In the 12th board examination, as well as in NEET and the IIT main, IIT advanced, the value of Kf or the Kb will be given. So no need to mug up this one. Don't waste your energy to mug up this one. Now let's see this numerical question. This numerical question is very easy. 45 gram, what the question here is? 45 gram of ethylene glycol is mixed with 600 gram of water. Calculate the freezing point depression and the freezing point of the solution. In this one, here Kf is not given in the NCERT book, but in the board examination, the value of Kf that will be given, and Kf for water is 1.86 Kelvin kg per mole. Okay, so same way, very simple, delta TF, that means depression and freezing point, that will be equal to Kf into molality of the solution. Molality of solution, find out firstly. So molality of solution, number of moles of solute here is ethylene glycol. So number of moles of ethylene glycol, that upon weight of water in kg. So number of moles of ethylene glycol, this one, upon weight of water in kg. So it is 600 gram. 600 grams converted to kg divided by 1000. So that much will be in kg. Number of moles of ethylene glycol will be how much? 45 gram. So number of moles of ethylene glycol, that will be equal to 45 gram here, that upon molecular weight of ethylene glycol. So here 12 into 2 plus 6 plus 16 into 2. So that upon molecular weight of ethylene glycol 62 gram per mole. Gram will cancel out. So number of moles of ethylene glycol this much. Number of moles of ethylene glycol will be 45 upon 62, that much mole. Here 0.6, molality is 0.6. So molality will be 45 upon 62, that much mole upon 0.6 kg. This is the main division line. So that's why that will be equal to 45 upon 62 into 1 upon 0.6, that mole per kg. That will 75 upon 62 mole per kg. That is molality. So depression in freezing point, delta TF, that will equal to Kf 1.86 Kelvin kg per mole into 75 upon 62 mole per kg. kg cancel out, mole and mole inverse cancel out, that will be Kelvin. So that will be equal to 1.86 into 75 upon 62. Okay, solve this one. So after solving, that will become equal to 2.2 Kelvin. So depression in freezing point of the solution will be 2.2 Kelvin. Depression in freezing point equal to 2.2 Kelvin. So what will be the new freezing point? So freezing point here has been decreased. Freezing point has been decreased. So new freezing point will be freezing point minus 2.2 Kelvin. And freezing point of water, you know, 0 degrees Celsius. That means 273.15 Kelvin. So freezing point of solution. So freezing point of solution, that will equal to 273.15 Kelvin minus 2.2 Kelvin. That will be equal to how much? That will be 270.95 Kelvin. Okay guys, very easy question that was. If you will solve by the concept, that will be helpful for you 12th board examination as well as IIT main, advanced and for NEET examination also. And put the formula, get the result, very easy. Now let's see here. Next question. This question here also same, very easily you can find out. Next one is osmosis and osmotic pressure. Watch out here, and this one is very important. Next, colligative properties is osmosis. What is osmosis? Osmosis is the movement of solvent particle from low concentration to high concentration through semi-permeable membrane. The movement of solute particle from low concentration to high concentration through semi-permeable membrane, that is called osmosis. As for example, this is a container here. Here is inside this container there is solute. Here is solution here, that means solute and solvent both is present in this one, and here is only in this container there is only solvent. Here there is only solvent. So solvent particle will flow from this one to this one. That means the solvent particle will enter inside this container, and this phenomena is called osmosis. There is semi-permeable membrane. Usually the goat's urinary bladder or pig's bladder or the parchment paper or the cellophane, they are used as semi-permeable membrane. That means pig's bladder or cellophane, that is used as semi-permeable membrane. So osmosis is the movement of solvent particle from low concentration to high concentration through semi-permeable membrane. The movement of solvent particle from low concentration to high concentration through semi-permeable membrane is called osmosis. Okay. Now, what is osmotic pressure? Watch out the next one. Watch out in this diagram. In this diagram, usually what happen, the atmosphere creates the pressure over this one. Atmosphere also creates the pressure over this one. So what happened, through this semi-permeable membrane, this solvent particle will flow from this solvent from pure state to the solution. That is osmosis. If you will exert the pressure, extra pressure you apply extra pressure over this solution, then the flow of this solvent particle from this container, that means from pure state to the solution, that will decrease. Why? Because atmospheric pressure is exerting over this both the solution. Naturally, when the solvent particle will flow from this container to this container, the level of this solution, the volume of this one will increase. And when you are applying this pressure, that means you are not permitting the rise in the volume of the solution. You are not applying, that means by creating the pressure, you are not allowing the movement of solvent particle from this container to this container. And by increasing this pressure, a stage will come when there will be no appreciable movement of the solvent particle from this container to this container, and that pressure will be called osmotic pressure. Osmotic pressure, that means at which pressure the movement of solvent particle stops from this pure state to the solution. That pressure will be called osmotic pressure. So osmotic pressure will be defined as the minimum excess pressure, because you are applying extra pressure here, this one. So the minimum excess pressure which must be applied over the solution to prevent the movement of solvent particle from pure state to the solution, that is called osmotic pressure. The minimum excess pressure which must be applied over the solution to prevent the movement of solvent particle from pure state to the solution is called osmotic pressure. You may write that the minimum excess pressure which must be applied over the solution to prevent the movement of solvent particle from pure state to the solution, that is called osmotic pressure. And expression for this osmotic pressure is same as that of gas law. In gas law, you know PV equal to nRT. PV, gas laws, PV equal to nRT. Osmotic pressure indicated by pi. So pi V equal to nRT. So this pi will be equal to n by V RT. N by V, number of moles of the solute upon volume of solution, that is concentration. So that's why pi equal to CRT, concentration in terms of molarity. That's why this value came, pi equal to CRT, or pi equal to n by V is RT. And that's why here pi V, the value of n you put that, and the finally will be M2 equal to W2 RT by pi V. This one very easy it is. This one very easy. The value of N, you can put that W by M2 and RT. This one. Now let's see. Now this question. What is isotonic solutions? So obviously iso means same and tonic means osmosis. So the two solutions which have same osmotic pressure, that will be called isotonic solution. Hypotonic solution means whose concentration will be hypo, means whose concentration will be less, and hypertonic solution whose concentration will be more. Now watch out this question. This question is here, volume has been given. This much of aqueous solution, the solution's volume of solution has been given and the mass of protein has been given. The osmotic pressure of such a solution at this one is found to be this much. Osmotic pressure has been given. Calculate the molar mass of the protein. Very simple it is. Guys, one point keep in your mind that osmotic pressure, that means among all the four colligative properties, that is relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmosis. The osmosis is used, or the osmotic pressure is used to determine the molar mass of polymer, because at lower temperature, the values of this one, elevation in boiling point or depression in freezing point, will be very less, but the value of osmotic pressure will be, you can measure. So there will be very less. You will feel very difficulty. That means in the case of elevation in boiling point, depression in freezing point, or in relative lowering of vapor pressure, the value will be so much less that it will be very difficult to observe. But in case of osmotic pressure, you can observe them very comfortably. In addition to that, at greater temperature, the dissociation of the polymers may take place, but in case of osmosis, the dissociation of the particles will not take place. Okay, so now here, very simple here, this is volume here given, bar, this one is given here. So you know already pi equal to CRT. By that formula, you can very easily solve this question. Now, more then after is a very important topic is reverse osmosis. This reverse osmosis is frequently asked in the board examination in 2 marks, and very easy it is. What is here? Just go on the previous, goes on the previous one, previous diagram here. Here, when you have increased the pressure, the movement of solvent particle from this solvent to this solution has decreased, and at osmotic pressure, that there was no appreciable movement of solvent particle from this container to this container. If this excess pressure will be more, then there will be movement of the solvent particle from solution to the solvent. That means what naturally happening, that will be, there will be reverse of that when the pressure greater than osmotic pressure will apply over the solution. So in reverse osmosis, when the examination will in the 12th board examination, question asked, what you will have to write? So reverse osmosis is the phenomena in which there will be movement of solvent particle from solution to the solvent when the pressure greater than the osmotic pressure apply over the solution. Reverse osmosis is the movement of solvent particle from solution to the solvent through semi-permeable membrane when the pressure greater than osmotic pressure will apply over the solution. That one point you will have to write. Second point, its use you will have to write. It is used to purify water. So RO means reverse osmosis. The RO which you uses in your kitchen, that is reverse osmosis. So reverse osmosis is used to purify the water. Okay guys, so that was about the reverse osmosis. Let's see. Then after here, these three questions here. There is this 1, 2, 3, 4. These 4 questions you solve at your home. In the next examination, we will also discuss about that. Now, then after this, about the abnormal molar mass. About abnormal molar mass, or about that is Van 't Hoff factor. We will discuss in the next class. That means the elevation in boiling point, depression in freezing point, relative loading of vapor pressure and osmosis. We have calculated by considering that there be no dissociation or association of the particles takes place inside the solution. So when there will be no dissociation or association of the particle will take place, then how much there will be relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and the osmotic pressure will be, we have studied. Now by the Van 't Hoff factor, we will study when there will be association of the particle inside the solution or the dissociation of particle inside the solution, then what will be the relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and the osmotic pressure. We will discuss in the next class. Today it's all for this class. In any case you have any problem, you may ask me in the comment box. Okay, it's all for the class. Thank you, Team Educate.